correctly balanced. But answers A and C were correctly balanced, but there was a deliberate wording in here which was feasible. So it's telling you which of these is feasible. So this is about halogens and about displacement reactions. In equation A, this is potassium chloride reacting with iodine. In equation C, it's a potassium iodide reacting with chlorine. So it's the other way around. Group 7 get more reactive as you go up the group, or less reactive as you go down the group. And so iodine is less reactive than chlorine. So iodine isn't sufficiently reactive enough to kick this chlorine out of the compound that it started life in. So actually here, chlorine is more powerful than iodine. So chlorine goes into potassium iodide, kicks out the iodine and takes the potassium for itself. So C is a feasible reaction. A was correctly balanced, but was an unfeasible reaction. So moving into question 10. More specific questions about electronic structures and about how to identify electronic structures from the periodic table. But we've got two elements in the same group. If we have two elements in the same group, what they will have is the same number of outer electrons. So again, it's like the previous question. So W and Z will have that situation. None of the other ones have the same final number. Which element is a metal? You have to look at the periodic table. Again, as we said, metals generally towards the left-hand side of the periodic table. They will have fewer electrons in their outer shell. 2,1 will be a group 1 element, well and truly in the metallic section, region 1 on that other previous question as well, telling us that the answer there is V. Two elements are gases. Going to need to probably work out what the substances actually are within the periodic table, but if you look at the electronic configurations, work out whereabouts they are in the periodic table. V, as we've said, is a metal. This one is lithium. W is a 2,6 configuration. This is oxygen. 2,8,4 is silicon, which is a solid. Oxygen, obviously, W being a gas, that's one of the answers. Y is nitrogen, 2,5, and Z is sulfur, which again is a solid. So the two gases are oxygen and nitrogen. So that's W and Y. And then, as we've said, sulfur. Sulfur has atomic number, proton number of 16. So we know it's going to have 16 electrons. And we can organise that in an electronic configuration of 2,8,6, which is given as the element Z in that final question. And then if we go into question 11, this is the final section on the Earth's atmosphere and the final area that we looked at this year. And which process was important? So what we're looking at is the early Earth. It's covered in volcanoes, mostly carbon dioxide and water. And then nowadays, obviously, we now know it's nitrogen and oxygen, 78, 21% respectively. And we know that we've had to reduce the amount of carbon dioxide in the atmosphere, and which process was very important in doing that. Obviously, photosynthesis, generation of plants allowed photosynthesis to occur, carbon dioxide levels then reduced, kicking out oxygen, obviously, which is then useful. Combustion generally produces CO2, as does respiration, and distillation is just a physical process of something becoming liquid, gaseous, back to liquid. So, process of reducing carbon dioxide allowed which gas to become more concentrated. So obviously, this process of photosynthesis took in the carbon dioxide, but gave out the oxygen, okay, as a byproduct essentially of photosynthesis. Okay, the water was obviously already there. Nitrogen came through from something else later on in this next question. This was then where the nitrogen come from. So which gas did nitrogen form? So it came from volcanoes, obviously, which were kicking out a gas. That gas was actually ammonia, NH3, which we saw in a previous question in the balancing equation section. Methane, natural gas, the formula of CH4, so no nitrogens in there. And obviously CO2 and H2O don't even contain nitrogen, so we know it's not those two. But ammonia, NH3, converted to nitrogen, mostly by bacteria in plants and things like that. but that's where it came from. It wasn't released as the actual gas itself. It was a chemical process from the breaking down of ammonia, which was released by volcanoes. So, and then obviously we're now looking at pollution and about how we're now and how man are changing those concentrations essentially. And sulfur dioxide is one of these things. We release it when we burn fossil fuels and things like that. So the sulfur is contained within the earth. We dig it up as part of oil and coal, etc. We burn it, which forms into the oxide. And the problem with that is generally acid rain. Sulfur dioxide dissolves in water to form a acidic solution, which then rains onto trees, etc., etc., causing them damage. And another effect of pollution, this next one, is this particulate type of situation. And particulate is a fancy word basically for bits of solid. So those bits of solid go into the atmosphere and they literally block out the sunlight. They get into clouds, so particulate damage, you can breathe them in and things like that, but ultimately in the atmosphere the pollution effect of that is global dimming, because it is literally pieces of solid suspended in the atmosphere, and that blocks out the sunlight. Okay, and that causes less sunlight to get to the Earth or to the Earth's surface. We're obviously changing the levels of carbon dioxide because of combustion of fuels, and the effect of carbon dioxide in the atmosphere, as we know now in various subjects, is global warming. It forms a nice protective blanket over the Earth, but unfortunately that's not so good for releasing the heat, and ultimately we are warming up the planet by the release of carbon dioxide into our atmosphere. Deforestation doesn't help, obviously, because it cuts down on the amount of carbon dioxide that can be locked up. Forest fires obviously are helping to do that, and acid rain, as we know, is due to sulfur dioxide in the previous question. So global warming is the effect of carbon dioxide. Carbon dioxide is a greenhouse gas, remember, and that causes global warming. So during that combustion we're releasing carbon dioxide. However, if we don't release the carbon dioxide properly because we haven't given it enough oxygen and we've done something called incomplete combustion, what do? Obviously the two possibilities we can have are either carbon monoxide or carbon. Obviously carbon dioxide is what occurs in complete combustion. So that's the answer to the kind of situation in the previous examples. We've got enough oxygen to form dioxide, so 2 oxygens. So if we don't have enough oxygen, we start to produce carbon monoxide. And if we don't even have enough oxygen to form 1 oxygen, we will ultimately form carbon. Carbon, though, is a solid. The question is asking for the gas. So we know that it's got to be carbon monoxide in this example. Carbon, being a solid, obviously not a gas, not the answer to the question. Carbon is one of the particulates in this example up here, okay, released by exhaust from cars and things like that. So if we don't have hardly any oxygen to make the combustion occur even incompletely, we generate carbon as a solid particulate. We get some oxygen in there but not quite enough, we generate carbon monoxide, and the problem with carbon monoxide is that is ultimately poisonous to us. Okay, as we've said previously, acid rain is sulfur dioxide, global dimming is the solid particulate, and global warming is due to carbon dioxide. Okay, so carbon monoxide has a much more direct effect on us in the sense of it's poisonous to our red blood cells and stops them carrying oxygen around the body. So it's a very quick run through of the answers there. Obviously if you need any more assistance, let one of your teachers know, but they are the answers with a little bit of commentary to go with them. As I say, pause, rewind, get yourself a piece of paper and a periodic table, have a look through those, use the lessons this week to see how you go. And if there's any questions, let your teacher know, and we'll see how you go. So well done. Thank you.